I work mainly on the digital end of barcode design. And the first project I worked on was converting some discrete logic into ASIC logic for decoding the barcodes. There's two ways of decoding U.P.C. barcodes. One is hardware and software combined, and one is strictly software. We took a hardware-software approach because that gives the highest speed of decoding. And basically we detected fields, that is 4 to 6 digit blocks that are used in combination to form the U.P.C. codes. The EAN and U.P.C. code consist of 2 blocks. The zero suppress code is a single block, and there are some D labels which I believe have been written out of the spec now, but they went up to 5 different blocks of barcodes. Now, the other component was determining when a label was present. In the first scanners, there were beam breaks on the scanners, so that provided a break. When an scanned object broke one beam, that told it was in the field of view. When it broke the other beam, it was out of the field of view. So that was relatively simple. The logic collected all the fields that were decoded by the hardware and then used software to stitch them together to form a label. In later designs, the beam breaks were eliminated, so that portion also had to be done in software. The problem without beam breaks was that if you weren't careful, you decode the same label twice, or you might mislabel. So it required some judgment as to typical speeds clerks used, and it turned out to be reasonably reliable, but that required a little bit of doing. The first ASIC implementation of the decode logic consisted of 4 chips, and that was mainly because at the time that was done, in the early 80s, 5-micron process was relatively common for standard cell design, and the logic density wasn't that great. In addition, the speed wasn't that great, so we needed a clock rate of 40 megahertz to decode the label, so we had to implement part of the logic in TTL logic, a minor portion, but most of the decode logic was done in the ASICs. In later generations, we cut that down to 3 chips and finally down to a single chip and performed more functions. So the last scanner I worked on consisted of single chip decode, a microprocessor, and that took care of, that was most of the design other than an analog section which Peter worked on. One other thing that came up, which was significant in the design, is that on bottom scanners, the early scanners, had a window which got easily scratched. And there was talk of replacing it with sapphire windows, which some manufacturers used, but those were limited in size and very expensive. In going to a side scanner, though, the problem essentially disappears. So that was another improvement that was made in scanner design, going to side scanning. Later on, other scanner designs incorporated both side scanning and bottom scanning. Some manufacturers put both functions in one single unit, and there were some designs that used 2 units that operate in conjunction with one another. And today, I believe much of the logic is being done in software rather than a dedicated ASIC. But a dedicated ASIC will give you the maximum possible speed in decoding the labels.